If you just start versioning willy-nilly, your clients stay happy, yes. Your developers, on the other hand, not so happy.
No one would even attempt to do this over 20 version changes, right? With if statements, it would be absolute spaghetti code.
What if, instead of duplicating the API, we do the same thing we do in databases or in Git? So your clients work on the version they want, and your developers develop the version they want. Everybody's happy.
I mean, that's kind of like... Today, I'm joined by Stanislav of Monite, and we're going to talk about that most holy of API subjects, versioning. And Stanislav, we recently came across a post he did on dev.to that we'll talk about now, about his solution to versioning at Monite and the open source library that he's released. So worth sticking around. And we also have a masterclass in versioning coming soon to the channel. So make sure to subscribe and get notifications so you can catch up. But let's go meet Stanislav. Hey, Stanislav, how's it going?
Hi, Josh. It's going really well.
So why don't you tell us a little bit about yourself and your background?
So I'm the tech lead of platform engineering at Monite. Essentially, I help my teams stay efficient and at the same time keep the excellence, the technical excellence in the company. I have a huge background in open source. I have contributed to many libraries, a few times even to C Python. So I try to stay with the open source community, try to help people, even if it's just volunteering. And yeah, my biggest passion, I guess, is making sure that developers stay happy during and after development. These are the things that I'm focusing on.
Yeah, that's music to our ears, the developer joy. I think that's a great thing that we can be aligned on. And so you do this at Monite. Just very quickly, what does Monite do?
Monite provides you with invoicing infrastructure for large businesses mostly. We do everything. We do accounting integrations, payments integrations, invoicing, both payables and receivables, both the invoices that you get and the invoices that you make. And we try to automate the entire process so that large businesses don't spend years building their own solutions, only for them to end up meh.
Yeah, makes sense. Makes sense. Big fans, obviously, what you folks are doing as a former Stripe as well, so somewhat familiar with the space. But what you started working on, I think, stemmed from some of the challenges you faced at Monite, right? Let's talk a little bit about the versioning problem and frame, the problem before we get into the cool solution that you've worked on.
So we are at Monite, we are an API first company. Our main product is our API. And as a result, when you provide API to dozens of clients, just like Stripe, we get into the situation of we thought that the space looks like that. We had a certain set of features, a certain set of thoughts about what it should look like. And then when the business changes, or when we realize that we made a mistake, we got to change the API. Sometimes it's just because we need to keep our API beautiful so that it's really easy to integrate with us, so that the integration takes, I don't know, less than a week, sometimes less than a day. And sometimes it is because we cannot add a new feature physically without breaking the API. And in order to make sure that our clients are still happy, that they don't have to change their integration with us a few times a day, a month, a year, whatever, we have introduced the API versioning. And I guess it's best practice to have some sort of API versioning in your APIs. But many people quickly realize that if you just start versioning willy-nilly, what happens is your clients stay happy, yes. Your developers, on the other hand, not so happy.
And they're not happy because they're having to maintain these multiple versions. Is that right? It's like just the workload it creates on the engineering team to support multiple products effectively, right? Is where the problem comes from. Okay, so I think this is a problem most people who work in APIs will be familiar with. And I think there's a variety of solutions from, we maintain and support all of the versions to we just break customers all of the time, or users, if you're not a business, but you have an API. So it sounds like, you've identified something, funny enough, I think came out of somewhat inspired by Stripe's practices that you are deploying at Monite. So tell me about this solution. Describe the solution to me.
So at some point, we came up with Cadwyn, which is the framework that I've created for making API versioning easy. the core of the approach here is that we are not actually supporting every API version. So when you think about API versions, you might think of individual endpoints changing, or you might think about the entire API being duplicated. Well, truthfully speaking, for big APIs, it's going to be the entire API, especially to the client. But what if instead of duplicating the API, we do the same thing we do in databases or in Git? We have one latest version, and then we use migrations, just like in the database, to go back and forth. So, for example, in the database, you will have a set of migrations which would allow you to build up your database schema from its very beginning and until, I don't know, yesterday's migration. And if you need to downgrade, you also have migrations for that. So Cadwyn does the same thing, but on the API level. It allows you to essentially define your latest version, work in your latest version, your developers are happy, they're supporting only one version, and then each time you make a breaking change, each time you introduce a new version, you describe a small set of changes between the versions, which usually include, some field changed in our OpenAPI schema. Then we describe how to convert the requests from the old version to the new version, and then we describe how to convert the responses back. So the request comes, Cadwyn converts it to the latest version. Your developers don't need to worry about anything. Then your developers, your business logic handles everything. You return the response, and then Cadwyn takes care of returning the right response version to your clients. So your clients work on the version they want, and your developers develop the version they want. Everybody's happy.
Interesting. So let me see if I've captured that correctly and make it real. So let's imagine I've got an API, and it returns a bunch of JSON, and in V1 it returns a field called foo that is a number. But then you decide, for some reason, in V2, you want that foo to be more complex than a number. Maybe it's now an object. And so it returns an object with a number that was the original number that foo was set to, and some of the metadata that says, the type or something, right? That would be a breaking change to an API, because the clients that were developed for it previously would break when they tried to read foo as a number. So what you do is something like you would write a migration that says, because you have enough knowledge to sort of recreate that old world, the V1 world from the V2 world, you would write a migration that plucks out the number from the object for a V1 client. If a client identifies it wants V1, and sends back the old format of the API. Is that a fair description?
Precisely, yes.
So let me just share my screen and sort of draw what the mental image I have here of what you're describing. So I'm going to use Excalidraw, which I'm sure everybody loves. So let's imagine, over here we have a V1 client, and in the original world they are calling V1 of your API, and so this is the actual implementation I'm looking at here, right? So easy peasy. But then you build V2 of your API, and you have a V2 client, and that's pretty easy, with the caveat that now the engineering team is supporting, both V1 and V2, and you're saying that's the thing we kind of want to fix here. So what you do is you come up with, Cadwyn in this case helps you to come up with some kind of almost versioning proxy or go-between that takes a V1 client and maps it to the V2 API so that it's no longer breaking, and you can now get rid. You don't need this V1 implementation. And then you can carry on doing this, right, to the point where you have a V3 client and a V3 API. And this is easy. The V3 client calls the V3 API, but now you've kind of got a chain effect. So this, let's not call it V1 client. Let's call this V1 to V2 mapper. And then we're going to do the same thing here. A V2 2 to v3 mapper. And this now chains to this, calls this, and we're back to this beautiful world where we still only have one version of the API, but they start to chain these effects. And so I now have effectively achieved backwards compatibility for V1 and V2 clients, which is something of a glorious place to be, honestly, for most API developers. But I'm only really maintaining one version of my code. Is that a fair sort of diagram of how Cadwyn works?
Yeah, precisely. And the biggest thing here is that these version change modules, they only know about the previous version and the next version. They don't know about any other versions. They don't care. And as a result, they don't change. You write them once, and most likely you will never need to change them, unlike your business logic.
Which is really important, because what often happens when you try and achieve this, what I've seen in code bases, because remember, V1, V2, V3 is often actually V1.1, there's like, many hundreds of changes potentially. And the code gets modified inside the API to deal with these, and it gets laced all over the code base. And it becomes very spaghetti-like to understand the sort of sequence of migrations and how they're applied. So by taking a structured approach like this, I have a very clean code base that is very constrained to, like, this is how I go from V1 to V2, V2 to V3, and that shows me all of these step incremental, I like the word migrations, I'll keep using that, migrations between versions, right?
Yep, precisely.
I think it'd be great to see a demo of Cadwyn and actually see some code. Like, people love to see code, right? So let's see it. Show us, Stanislav. Show us your code.
Let's try it out. What we do first, as always with Python, let's create our ven. I recommend everybody to use some package managers such as Poetry, but today we're going to be using ven. Okay, source.
And just while you're doing this, does Cadwyn work only with Python, or does it support other languages?
So Cadwyn only works with Python by default, but Cadwyn is not just the framework. Cadwyn is also a path of learning for me, where I essentially researched the entire internet to find everything related to versioning. And so I have found frameworks in other languages that do similar things. Obviously, not all of them are as feature rich, but the core idea, the most valuable thing, many of them implement. For example, there are frameworks like this in Ruby and Golang.
Cool. Awesome.
Yeah. And Cadwyn's documentation has all of them listed in the literature section. Okay, so we have installed Cadwyn. Now let's define the most basic API. First of all, let's start with fastapi. This is what Cadwyn is built around, but we're planning to make it wider soon. So let's start with a very basic fastapi app, and thanks to our super Maven here. And we would start it simply as tutorial.py. That's it. That would start our app, and we would see this page right here. Okay, this was a fastapi demo. Now, going to Cadwyn. Cadwyn is very, very similar to fastapi. So instead of importing fastapi, we just do from Cadwyn, import Cadwyn. Now we go here. And Cadwyn has a single required argument compared to fastapi. It requires us to have some versions defined, because by default, Cadwyn assumes that you have at least one version. Okay, version. Let's pick any date. 2008 23.
So in this case, you're using a date as the versioning identifier. Instead of a V1 or a V2, you're picking the date format, which is common in APIs, right?
Mm-hmm. Just like Stripe, just like Monite, we decided that date-based versioning is the least aggressive towards the user, the most visible, and you don't really need more than one dimension. So we're fine with just going, forward in time.
Yeah.
Okay. Now this should already work. Let's run it. Let's see it. Boom. So now, instead of getting our Swagger page, we are getting this Swagger dashboard with each version defined here. And so if we go to unversioned, we have automatic stuff that Cadwyn has created for you, and which we'll explore someday later. And we have our endpoint, the old endpoint that we have defined in Fast API. We also have this special page for this version, but it's empty. Now let's go and try creating an API, a proper API here. Let's start with a database. We will not have an actual database. We'll use just a simple dictionary, just a simple JSON. And let's say we are operating users. So in Fast API, you would define user create request. Boom. Let's say that our users have an address. Let's not go to the names. And then let's say that we also have a user response, or actually how we prefer to do it, so resource, which will also have the address, which will also have an ID. We'll use EUID here for simplicity, but anything goes. Okay, we have defined what's going to be in our Open API spec, what we expect in terms of data. Now let's create two simple endpoints, an endpoint for creating a user and an endpoint for getting that user. App post, users. Now we'll have user create request. And I think SuperMavin is going to do the rest for us. So essentially, we create the user with this ID, put it into the database, and then return it. A regular CRUD, like anybody else would do. Same would go for getting the user, just a bit simpler. Now, see how let's take a look at the page, at the resulting page. Our users' endpoints are now unversioned, because by default, everything Fast API we do in Fast API is unversioned. In order to make them versioned, in order to put them into the version category, we would create a router, which is a regular thing in Fast API, versioned API router. It's very simple, no arguments required. Then we define these users in this router. And then we would simply say app generate and include version routers and push our router there. And as simple as that, they are now versioned, and we can now see them in this default page for 2008-23. And if you create any other versions, Cadwyn will assume that these endpoints exist in all of them, unless you tell it not to. So by default, all versions that you create are, all endpoints that you create are contained in all versions, which means that, it's really easy to keep the versions in sync, unlike, when you're copying them, into every new version. Now, let's try creating a user here. Okay, we have created, let's see, 123 street, whatever. Okay, we got our user here, and 123 street. But now, let's say that we have a database full of these users that, at 123 street, 124 street, whatever. And now we get into this situation where the business comes to us and says, hey guys, we understand that we expected there to be only one address. We understand that there was only one address in our plan, but we now realize that some users might have multiple addresses and want to pick and choose which one they want to use depending on what you're providing. So, for example, at Monite, our counterparts are the businesses that we describe, both the individuals and the organizations. They have their addresses, and in order to for an individual to specify, okay, I want to have this address on invoices and this address somewhere else, for example, in the metadata in our system, we would need to have multiple addresses supported. And now this is going to be a simpler example. How you would do it without Cadwyn. You would just say, okay, this is addresses now, list of strings. You would also fix it here. Okay, list of strings. You would also fix it in the endpoint. All right, addresses, and that's it. If we check that, if we open it now, we'll have the addresses. We have everything expected, and we might have even migrated our users that we have created previously in the database. So a regular developer that has never seen APIs, that has never worked with versioning, might say, okay, everything's fine now. But no, many of our users are still using the old version, and many of our users will still try to create the addresses using the old version. They'll pass address, they'll get an error, everything's gonna go bad. And that's where we apply Cadwyn's magic. Let us create a version change class, which will also need these two things for. And we'll need to describe how the schema changed. Now, let me show you. Let us close these so that we see more. Now, here is what this version change class would look like. And actually, it will go here. So we describe, let's say, change address to addresses, version change. And then we have instructions to migrate to previous version. These instructions will help our open API generator show to the users the documentation page for an old version. So let's say we've migrated to version 2001, and the 2000 stuck in the past. Okay.
So wait a minute.
Yep.
There's something extra here. You're saying that the Cadwyn feature not only changes the API and the behavior, but also changes the open API that's generated to generate the older versions as well.
Yes. And it also generates the change logs for you so that you can distribute them to your users.
Wow. Okay. So it's not only implementing the versioning capability, but it's documenting it as well for your users, for your whatever order generation you might need to do for clients and SDKs and so on. All of that's going to be helped by using a framework like this.
Yeah, precisely.
Amazing.
And now let's take these schemas. Let's put them here. And now in Cadwyn's DSL, we describe, okay, user create request dot field, let's say addresses are actually, so here we're not describing how to migrate from 2000 to 2001. This is why they're migrating to previous version. And here we describe how to migrate back. And so we say had, so field addresses had name equals to address and type equal to string. So now it has, let me make that bigger. Now it has type list of strings and it has the name addresses, but in the past it was a single address with a different type. And same goes for our user resource. Okay, that's it. Cadwyn already has enough information to migrate stuff. Let me show you. We forgot to do a description. So each version change still has to have a description. This is what we will use in the change logs, and this will serve as an internal documentation to you and to everybody else at the company so that they don't forget why we actually did what we did. We'll use a dummy one here, but in general, I advise you whenever you're making APIs, and especially API versions, describe the why. Describe the why we did it. Now, let's open the old page again. Boom. Now we have two versions. 2000, which has address. Oh, sorry. We forgot to include this here. So yeah, we described, essentially, we described that in 2001, these changes happened right here using this class. And now we can see that in 2000 version, we have address. And for get, we would also get the address back, the user ID back, I guess. Let us help fast API describe that. Okay, now it shows that we will have an ID back. Let me make it bigger for you. And if we go back to our dashboard, 2001, we open it and we see that it's addresses. And same goes for reading it. Okay, now let's skip the boring part. That's only OpenAPI spec. Now, in order to convert the actual requests that come from the users, we use our converters. Convert request to next version full, user create request. And it's a little bit different, not like SuperMaven assumes it to be. We have request info here and response info here. So it uses its own custom DSL. Request info. And we don't need this. All right. And we don't need to return anything. So we go into the request body and we say request body address addresses equals to request body address, but a list. Okay, there is a lot to unpack here. Allow me to help you understand that. So what we do first is we get the address here. We get the address that is in the old request. We pop it from the body so it's no longer there. And then we create a new field within the request body and name it addresses and put that old address there. So this small function will convert every single request that uses this OpenAPI schema automatically, even if it's like 10 endpoints using it. And I guess that's also one of the benefits. We're not always defining them based just on endpoints. Sometimes sometimes it might be multiple endpoints using this.
So you're doing it that's just based on a shared schema component in the OpenAPI.
Yes.
Is that right?
Precisely. Yes.
Wow. Okay.
And so every single one of them that uses the user create request schema here will get migrated. And that's obviously Cadwyn has an option for specifying the full path, but this is the default mode that we work in. Same goes here. Let me show you. So we go request, body, response, body, and then we want to pop out addresses now from responses, because from the latest version, we're returning something with addresses because our business logic assumes that there is only one version, the latest one. Okay, we get our addresses and we return the first one of them. Let's not return, but we set the first one of them for the address. And that's it. This is the whole version change module, the one, the whole migration that we talked about earlier, that allows us to have versioning in Cadwyn's way. The cool thing about them is that you can have as many of them as you want, and it's probably not going to affect your performance at all, while at the same time providing you with all these benefits that we described earlier. Now, let's try that. Let's create a user on the old version. Okay, 123 Street. Boom. Okay, we got our user, we got his ID. Now, let's go to the new version and get that user from the new version. See? But instead of address, it's now being addresses. And same goes in the other direction. If we create another user with another ID, 124, I don't know, street. I'm not super creative with naming. Okay, we get an ID.
You could have gone for 123. I mean, it's pretty creative.
And then we get the user on the old version, and now we get a single address. And that, as I said, this is just a small example that demonstrates the power of it for a single case. But imagine if you had 100 of these versions. And that's exactly what Stripe has. They have, what, 12 years or 13 years already worth of versioning that they have to support. And somehow they survive and support almost all of the versions that they've ever created using the same approach that we use here, albeit with a little bit less automation. And that's Cadwyn.
So, I mean, that's kind of like when you think about, first of all, you showed an example, very common, where you didn't have the foresight to support multiple addresses in your first version of your API. You realize later you need to support an array of addresses, but you don't want to break backwards compatibility for that because, you know, you can pick the first address in some cases. So most people would think, yeah, I can solve this. I'm just going to put an if statement somewhere in my code. If v1, do this. If v2, do that. But then you'd have to maintain multiple versions of your OpenAPI document because that if statement's not going to fix that. And you'd probably have to do it for every endpoint, right? That uses that particular type. What you've just shown is that you can write a little bit of code that modifies a schema dynamically, that modifies the runtime implementation to create the versioning effect you need, and modifies the OpenAPI generation to match that. So now you've just got this stack of migrations, like we said, to maintain that's going to keep all of this working and so much cleaner. No one would even attempt to do this over 20 version changes, right? With if statements, it would be absolute spaghetti code.
Precisely.
Stanislav, that is nuts. In the bottom, we've got the links to Cadwyn. Go check it out. We've got the links to his dev.to article. Thanks, Stanislav.
Thank you.